Good afternoon. My name is Bill Henderson. I'm a major control machine out of Indianapolis, Indiana. We're a short 5 minutes from downtown Indianapolis, and we are a contract manufacturer of large, complex parts. These are sometimes fabrications, they can be forgings, and they also can be caskets. Who are and what we do? We have approximately 325 employees, we do $100 million in sales. We provide world-class manufacturing and precision machining, turning 43 feet in diameter, 5-axis milling, and welded fabrications were recognized by ASME in the various codes. Quality systems, we have CMM laser capabilities, non-destructive testing, pressure and vacuum testing, and we do assembly and finishing for very large parts. Our customer base includes many Fortune 500 companies, one of which is Siemens, Lockheed Martin, Raytheon, Caterpillar, BAE Systems, and we serve many, many industries. For example, aerospace and defense, big market right now. If you look down here in the lower left-hand corner, the barrel of that assembly down there, that is the Orion space capsule. That's the next generation NASA capsule for space exploration. As NASA says, this is the one that will get us to Mars. I'd like to see it get us to the moon first. But the lower part of this barrel right here, we manufacture our high-speed aluminum machine, which has the Siemens 840 control. Also, the center part of that, you see some components for a rocket engine. That's the RS-68 for the Delta IV rocket. We're also big in the national labs and nuclear industry. The center part of that, you see some components for the SNS project at Oak Ridge. The weldment you see down here is a very complex weldment, which is all Inconel. That thing is about 13 feet in diameter, and that's used for magnetic-based fusion reaction. Power generation, we do a lot of work for Siemens and Alstom, the hot gas sections, machining and fabrication. You can see in the lower left-hand corner, we also get in and do some very complex assembly work. Commercial, upper right-hand corner, you see the Hollywood Tower of Terror. We built the pulley system. Also, you see various components for Caterpillar, and we do some gas turbine components for solar gas turbine. So that's basically who we are and what we do. Once again, we're contract manufacturers. We specialize in large, hard, to manufacture parts. Large machining, we can turn up to 43 feet in diameter. Upper right-hand corner is a large vertical boring mill with 268-inch tables. On the left is our DSI gantry mill, which we have a total of 700 inches of travel in X, 240 in Y, and 180 in Z. Also, as you can see, it has a 236-inch rotary table, which is part of that 740 inches in X. We have a flexible manufacturing cell, which will handle parts in the 60-inch cube. That's integrated into with a CMM in it. So the part goes in, comes out, it's inspected. This is where we do a lot of our medium production work for solar gas turbine and Caterpillar. Welding and fabrication. This part over here in the lower right-hand corner was a third section of that Inconel weldment that I showed you previously. Upper left-hand corner is the exhaust for a Rolls-Royce gas turbine. It's a retrofit for the Royal Navy. Upper right-hand corner is another part for the SNS system down at Oak Ridge. All fabrications. Do a lot of fabrication work in the nickel alloys, and a lot of work now in the stainlesses with the ramp up to the nuclear business. So I'm here to talk to you about a retrofit program that we're performing in conjunction with Siemens, our retrofit, Indiana Automation, and Grandshop Probing. The reason we went to retrofit is we wanted to standardize one control throughout the shops. One control, the operators only have to learn one control. Maintenance people only have to learn one control. You only have to have 2 spare parts for one control. Programmers only have to learn to program one control. So this was driving the retrofit program. The other thing that was driving the retrofit program is our upper management had to make a decision. How did we want to configure the plant as we move forward to stay competitive? You got older machine tools, do you upgrade the machine tools, do you buy new machine tools? What's the best strategy to make sure that we're going to be competitive in the future? You see here on the left is a smaller vertical pouring mill. On the right is a Cincinnati U5 gantry mill. These, as you'll see later, these machines were part of the retrofit program. To get the whole thing started, we had 3 Cincinnati 10HC horizontal machining centers. We looked at these were purchased in the 1980s, 10 horsepower, Acromatic 900 control, no part or tool program. We said, okay, it's hard to replace a machine that's got 100 inches in X travel, 60 inches in Y travel. A little low on horsepower, no program. As you can see on the left, I'm getting a little ahead of myself here, but that's before. That's the condition of the machine before we did the retrofit. Acromatic 900 control. On the right is the machine after we did the retrofit. Siemens 840 DSL. Part and tool proving. And 20 horsepower. Basically a brand new machine. What I had as part of this retrofit was up, not only as you get into this, you see we use the Siemens control. We retrofitted mechanically as well. We went and redid ball screws, replaced ball screws, updated lube systems, rebuilt tool changers. So essentially we ended up with a new machine without buying a new machine. So as we got into this a little bit further, we also had 2 Cincinnati Mag U5 gantries. This is one table with two gantries. These had Acromatic 950 controls, no tool probing. We had another Cincinnati Mag U5 that actually had an older version of the Siemens 840D power line with no tool probing, and another U5 bridge that had an Acromatic 950 controls. So we said, okay, why don't we just go and we retrofit those 7 machines, the 310HCs and 4 U5s with 1 control, and we add part and tool probing and rebuild them mechanically. We said, okay, well that's a good idea. So the decision was made to take these 7 machines and retrofit them with the Siemens 840 DSL integrated with Renaissance tool and part program. And the retrofit itself, our retrofit partner in that is again Indiana Automation out of Noblesville, Indiana. We looked at this and we said, hey, we've got some other equipment out there. Why don't we just expand the program? So we ended up expanding into 12 machines, including 2 in our Plant 2 large manufacturing facility. So the whole program started out, we ended up doing 3 Cincinnati 10HCs, Acromatic, 2 gantries, 2 bridge machines, 3 birthday vertical pouring mills, 168, 157, 91-inch swing, a Webster Bennett vertical pouring mill, and actually a SIP jig board. So the decision was made that we're going to go ahead and we're going to retrofit all this equipment to have the same control, and it's all going to have tool and part programs supplied by Renaissance. Again, 1 control, standardization. So the question is, why did we pick the Siemens 840 DSL with 2 keys here, operate, software, and shop mount? One of the main things is we do a lot of 5-axis work, very complex 5-axis work, and a lot of the parts we only do one time. It's a one-time deal. We like the open architecture and the power of the 840, especially in the 5-axis area. The Traore, their rotary tool control point, as far as our programmers and our systems people, they said that's the best we've seen. For example, we do a lot of parts where we'll load on a right angle head a 2-axis contouring head, and Traore will track the tool tip for that 5-axis profiling work. If you see in this picture down here at the bottom, it's a 2-axis contouring head on one of our U5s, and mounted to that is a right angle head, and we can do full 5-axis programming in that configuration, and that gives us a lot of capability to profile up under a part without turning it over. We couldn't have done that without the Siemens capability in the 840 DSM. The other thing that was shown in the video, the work order frames, with our large complex parts, the setting of offsets becomes critical. And with the work order frame in the 840, in any offset you can fine adjust, you can rotate, you can scale, and you can mirror. Our operators really like this. It's real simple. They can go ahead and call the screen up. They can manipulate any set of offsets they want. Tool management, another big plus. We utilize PDM for our tool management system, and what we do is this: we load that down into our CAD/CAM system, and then that control, and it gets into the control full tool definition. The Tool Pro defines the final tool length. What's that do for you? Length and diameter, excuse me. Saves time, eliminates errors. How many times have you seen an error, a touch-off error, or a diameter error in making the machining parts? So the combination of the tool management system with the Pro is eliminating many, many errors. The other thing we like is the graphical interface in the operate software. What this allows us to do, if we're in a program right now, and say you're in a CAN cycle, a G84, G81 or something, and you want to modify a depth, or you want to modify a diameter, you know, basically you had to go in, you had to manually edit that program. Now you go in and you cycle to the right, you can bring this screen up, and you edit whatever you want to edit that program, whether it be your Z depth, your approach plane, your diameter. This is a helical interpolation cycle right here. And then that will update the G-code in the program. Again, you're eliminating errors because you're relying less on the operator. Very, very key function. Shop mill itself, we didn't initially start with the plan of putting shop mill in as part of this retrofit, but we got into it and said, hey, we're going to try shop mill. And we got a lot of older operators. And we run a lot for the variety of our parts and the amount of parts we have to program. We have to write a lot of programs in MDI for the simpler parts. Again, this is, you know, the guy sitting there punching in G-code. With shop mill, he can go in and define what he wants right on the screen graphically. And we've got operators that have been there 30 and 40 years at a grass shop mill, and they're using it daily, and we're seeing a lot fewer mistakes. This is a tricoidal milling routine right here. It defines the slot, the function, the diameter, enters it, and generates program. This is a big plus that we didn't see coming in when we started the program, which is very, very beneficial. How did we get all this done? Well, MTM's retrofit partner was Indiana Automation out of Noblesville. We're standing here in the red shirts. They are a Siemens solution partner. They had done business with us before, and they were a local business. So we selected them to actually perform the retrofits, and which I have to say was a total team effort. Indiana Automation became almost like an employee of Major Tool. They performed the control retrofit, including drives, motors, and electrical cabin. MTM maintenance technicians assisted IA in this phase. Got a couple of them sitting here in the back row. And our maintenance technicians also did all of the mechanical work on the machines. When I say mechanical work, we have new machines. As I said earlier, we redid the ball screws, we redid lube systems, we did chiller systems. And then all three of us together, MTM, IA, and Renishaw, collaborated on the probe interface and installation. Now, one of the things that has really come up on, and I missed this a little earlier, is one of the key points again to the 840 control and the open architecture was the ability we had to write macros. And this has really come out in the area of the Renishaw probing. Again, We have operators who've been there 30, 40 years. They want to use an edge finder. With the Renishaw probes and the macro capabilities of the 840 control, we've been able to write macros that where these operators have thrown away their edge finder. Now, I never thought I'd see that day. And I think, again, that shows you the power and the integration of what you can do when you put a team together to do a retrofit project, the power of the Siemens control, the abilities of Indiana Automation. And now we're not quite done yet. We've got 8 machines done. We're starting 2 more. The other 2 will start after the end of the year. But again, from my perspective in management, it makes things a lot easier for me. Again, operators, 1 control, maintenance technicians, 1 control, programmers, 1 control. I can take machinists now and move them from machine to machine to machine, and I don't have to worry about training. And that's something I don't have a slide in here, but I'll talk a little bit about the training aspect. Siemens came in and they did some training with our people, some programmers, some operators, and some maintenance people for 1 week. Then they became the trainers. I've got operators that were used to running old style controls that have learned to run the Siemens 840 in 1 week and been proficient. And I think that says a lot about the control. And again, if you went back and looked at the 3 Berthier vertical boring mills that were retrofitting, you can write a program, I don't care what machine you put it on. You don't need separate posts. You write it, it'll run an edit program, and it's seamless to that operator what machine he's running. Yeah, sure you have some differences in diameters and lengths and heights and whatnot. But again, from a management standpoint, it makes my life easier. I can't believe that it's gone as well as it has. I mean, we've struggled, but we couldn't have done it without Indiana Automation's help, without Siemens' help, and without Renishaw's help. So, at this point, I'd like to throw up if anybody has any questions. I've got Indiana Automation here with me. Luther Zimmerman standing here in the back, who's our lead CNC engineer. So if you got any of the technical type questions, ask those guys, but the technical side is not my strong point. So, does anybody have any questions? Somebody has to have a question. How much? Yeah, I've talked to Siemens about that. Actually, if you look at those 10 HCs, what it would cost to buy a machine of that size compared to what it costs to rebuild a machine of that size, it's a no-brainer. It's made us much more competitive. You hear us talk about setup time. If you take the definition of setup time, which is the time you finish running the parts you're on, the time you finish running the first good part for the next setup, is being your setup time, that's the whole production run for our part, because we're making 1 part. So, with the features of the Siemens, again, it's a new program. We use Vericut to verify our programs, along with the tool probing, along with the ease of the control. That, you can call it runtime, you can call it setup time, but we're starting to draw that down. We have a dedicated programming department, but like I said, we have to write hundreds of programs sometimes a week. When we get into the simpler parts, in the past we've always left it to the operator just to write a program in MDI, which means he's sitting there punching in G-code, M-code, feeds and speeds. It's time consuming, it leads to errors. With shop mill, I didn't think that I would see some of our older, more seasoned machinists actually start to use shop mill. There's another slide that somehow that this wasn't indexing the way that we missed in here, but during the course of this retrofit, we were also purchased a Jobs high-speed unlimited machining system with an 840 DSL control. And we also purchased a DMG DMU50 Eco, which is a small tool room type machine to put in our tool room. And we're using that to train our younger operators. And it also has the rent-a-shop, part, and tool program. So that's part of the overall manufacturing philosophy to move forward. Keep behind the scenes control on anything we get. Yes. Oh, yeah, it is. It's, yeah. The question was, you can't say that again. But, you mean our programming system? Our offline programming system is CATIA. Okay, we use CATIA in conjunction with Vericut, and then TDM is our tool management system. But what we're doing at the machine is with the shop mill, and like I said, we have one machinist that's been with the company 52 years now. And when we started to put he operated a 10HC. And when we started a retrofit project, and we started on the 10HCs, we actually did a U5 first. And Ray thought it was time to retire. He'd been running an Achromatic, and he thought it was time to retire. Well, our owner talked to Ray, and some other people talked to Ray, and Ray said, okay, if you do my machine last, I'll stick around. Which leads me to a little sideline that kind of talks about our company management. When Ray got his 50-year seniority, it was the all-employee meeting, and our owner was talking about Ray, and he says, you know, what do you give the guy that's been here 50 years? You know, do you just give him a Rolex or whatever? And so, while Steve's talking, coming in through the side doors, a brand new CTS Cadillac with the license plate MTM 50. I think that says a lot about the management of our company. And that's also why we're doing this retrofit program, so we can stay competitive in the future. But, back to my story. Ray is now running an 840 control and using probes. So I think that tells you the ease of the system and the thought that went into the retrofit program and how successful it's been. And the productivity of those 20 HCs with the added horsepower, the new control, and the probe has been phenomenal. I can't say enough about that. Any other questions?